In this problem, we are going to maximize profit. So we've got a manufacturer of widgets with the following relationship between price and weekly demand. So that's X equals F of P equals 40,000 e to the negative P over 200 for prices between 0 and 391.09. We've got a cost of running the factory is 175,000 and the unit cost for each widget is $43. Okay, we want to find the price that the company should set to maximize their profit, and we want to know what this profit is, what the absolute maximum profit. Okay, so usual strategy here, we want to find the profit equation, find critical numbers for the profit equation. If there is, and if we're lucky, there's one critical number between 0 and 391.09. We can use the first derivative or second derivative test to look at that critical number to see whether or not that represents a maximum or minimum. If there's only one on an open interval, then it's an absolute maximum or an absolute minimum. Hopefully it comes out to be an absolute maximum, comes out to be a critical number with either the first derivative test increasing then decreasing, or second derivative test a negative second derivative. We'll decide how to approach this when we get there. That will be our price, absolute maximum, plug that price back into the profit equation. Okay, so we've got a little bit of work to do though first to find the profit equation. I know that profit is revenue minus cost, so I better figure out my revenue equation and my cost equation. The revenue is pretty straightforward, so let's just write those down. Revenue is P times F of P, which is 40,000 P e to the negative P over 200. Cost is a little more painful because we know each widget costs $43, but we want a function of price. So it's going to be 175,000 plus 43 times F of P. So 43 times 40,000 times e to negative P over 200. Okay, so let me pull out my calculator and do 43 times 40,000. Oops, 43 times 40,000. And I get 1,720,000. So my cost equation is 175,000 plus 1,720,000 e to the negative P over 200. Okay, so now we've got a profit equation, which is revenue minus cost. Let's just write that down. P equals 40,000 times P e to the negative P over 200. Again, we've got capital P for profit and lowercase p for price. That's the profit, that's the revenue, and we want to subtract costs. That's minus 175,000. Just going to be really careful, put some parentheses there, plus 1,720,000 e to the negative P over 200. Okay, and parentheses. Just need to be careful of those parentheses because the second term is going to be minus. Okay, we want to find critical numbers, so we take the derivative. So that's our profit equation. Derivative P prime equals, okay, we've got a product rule here, so that's 40,000 e to the negative P over 200 plus 40,000 P times, the derivative here is negative 200 e to the negative P over 200. Minus the derivative of 175,000 is 0, and so we get minus this. Oops, this should be 1 over 200, sorry. A minor mistake. And minus this, which we're going to get minus, we got a minus and another minus, sorry, right? We're going to get a minus from this derivative here. So we get minus and another minus, we're going to get plus 1,720,000 divided by 200 e to the negative P over 200. Don't need that parenthesis. Okay, there we go. Okay, so what do we end up with here? Let's just simplify a little bit. We've got 40,000. So the first term and the last term do not have a P in them. So we get 40,000 plus 1720000 divided by 200. So that's going to be 344,000. Hang on a second. 1720000 divided by 200 is 8,600. I thought I did something wrong. 8,600 plus 40,000. So this is going to be 48,600 e to the negative p over 200. We've got a plus here and a minus here, so we're going to get minus 40,000 divided by 200. It's 200, so we get minus 200p e to the negative p over 200. Okay, set this to 0, so this is our derivative. Critical numbers, so set that to 0. 0 equals, I'm going to factor out this e to the negative p over 200 times 48,600 minus 200p. 200p. Okay, now if we look at it, this term is never 0, so this term must be 0 in order for a critical number, so that's 48,600 divided by 200. So let's just calculate that. 48,600 divided by 200, 243. That's not a very nice price. Okay, so 243 is our critical number. There's only one. Now, given the problem, we would guess that this represents a maximum. But let's just check. Now, just trying to think here, we've got this form here for our derivative. So let's draw, I like the first derivative test. So we want p prime. We've got a critical number 243, so it's 0 there. And let's choose a small price relative to 243. Again, smaller than 243, bigger than 0. Doesn't really matter what. If we look at this, right, e to the negative p over 200 is just some number. And we got 48,600 minus 200 times, let's say, 10. Well, that's positive. If those terms are positive, e to the negative p over 200 is positive, so we have a positive here. We choose a larger number, like let's call it 300. We know we end at 391.09, so we'll choose like something like 300. And we go, again, same thing, e to the negative p over 200 shows up both terms and is positive. 48,600 minus 200 times 300, that's 60,000, so that's negative. We're increasing, we're decreasing, so this represents a local maximum, but because we have an open interval, it's going to represent an absolute maximum. So we know the price is 243, and now we need to find the profit for 243. So we're going back up to our profit equation and plugging in. This isn't going to be fun, but we'll use our calculator. So 40,000 times 243 times e to the negative 243 divided by 200. So this is our revenue minus 175,000 plus 172,000 times e to the negative 243 divided by 200. Close parentheses once and twice. I get 2,198,680. So 2,198,680. So let's check. 2,198,680. Got the right answer. Okay, so that's how we solve this problem.